Unit 3, Chapter 1, From Esters to Biodiesel. Before we get to know biodiesel, we need to revise our esters first. So what are esters? Remember, they are the molecules with ester functional group. It is produced by reacting an alcohol and a carboxylic acid, and that reaction is called an esterification reaction, or you can call it condensation reaction. So the ester functional group consists of two parts. The first part is the carbonyl group. This carbon double bonded to oxygen that's used to be part of carboxylic acid. And the other part is the alcohol part, that is the alkoxy group, which means that it is an alcohol losing an H that's attached to the hydroxyl group. So the general formula writes like this, and for us, we must be able to tell that which part used to be the carboxylic acid and which part is the alcohol. Okay, so here in the general formula, the R stands for hydrocarbon chains. Yeah, so this red R on the left-hand side, that's directly connected to the carbonyl group. That is the carbon double bonded to the oxygen. And this part, this hydrocarbon chain, used to be in carboxylic acid. And the other R, the other hydrocarbon chain, that's directly connected to the oxygen in the ester functional group, used to be from alcohol. Here is an animation of condensation reaction. You can see that an ester is made by two molecules combined together, losing one molecule of water to make ethyl propanoate. Let's have a look again. So here you can see the carboxylic acid is losing the OH, and the alcohol only lose one H, and they make one water, and the remaining becomes an ester. So you can see that all esterification reaction are condensation reaction because they all lose one small molecule of water. But not all condensation reactions are esterification reaction. Okay, so not all condensation reactions make esters in the end. Here is a general formula of an esterification reaction. So carboxylic acid losing its OH in the functional group and alcohol losing an H to make water. The result, the remaining parts combine to make an ester. This reaction requires concentrated sulfuric acid as a catalyst. Okay? At the same time, you can see that this reaction is actually a reversible reaction. That means the products thus made, the ester, can react with water again, and water can be added back to make a carboxylic acid and an alcohol. And this process, adding water back, is called hydrolysis. So in this general formula, you should notice that for most organic reactions, we don't really care about the hydrocarbon chains. So that's why we shorthand it into R. Okay? It is the functional groups that matter in this reaction. Naming esters. Esters all have first name and last name. Their first name is from alcohol. We are changing the alkanol to alkyl. And their last name is from carboxylic acid. We are changing oic acid to O8. And for this reason, to be able to name an ester, we must know which part comes from the alcohol and which part comes from the carboxylic acid. Here's an example. In this case, we are reacting an ethanoic acid with a propanol. Okay, so the resulting ester would be propyl because that's the alcohol and that's the first name, and the ethanoic acid becomes ethanoate and that's the last name. Here are two more examples. To be able to look at an ester and be able to name it, we must first revise and memorize the name of different numbers. Okay, so we have to at least memorize number 1 to number 10. Let's look at here, this ester. We find out this functional group here, that's the ester functional group. So whatever that's directly connected to the carbonyl group is from carboxylic acid. And whatever that's directly connected to the O, to the oxygen, is from the alcohol. So here, in this case, we have a methyl and propanoate. Okay. In this case, we also find out the ester functional group, but you should see that this functional group is written in the other way around as compared to this one. But that does not change the fact that this carbonyl group used to be the carboxylic acid. And since this part only has one carbon in it, it will be a methanoic acid. So in this case, it is a butylmethanoate rather than a methylbutanoate. Okay? Remember, this part is a carboxylic acid. Before we said that the hydrocarbon chains in an ester doesn't really matter. It is the functional group. So therefore, we can easily change the carboxylic acid to a very, very long ones. In your data book, they give you a list of carboxylic acid. You can see that all of these molecules are carboxylic acid. The only difference is that they have very, very long hydrocarbon chains, and we call them fatty acids because they're an essential component of oils and fats in our bodies. Okay, so these esters, okay, with very long hydrocarbon chains, especially with those fatty acid chains, are our biodiesel molecules actually. So biodiesel on a molecular level is simply a mixture of esters. And it takes a general form of an ester where you need to know that this R is from a fatty acid. Okay, they're very, very long carboxylic acids. Okay. The length of R ranges from 10 to 20. And the alcohol part, normally in reality, we work with methyl, ethyl, and propyl, which means that we can use propanol or ethanol or methanol to make a biodiesel molecule. However, in VCE, we mostly just deal with methyl. So in VCE, we can say that almost all biodiesel molecules are methyl esters. Now, pause this video for a sec and try to write an esterification reaction between linolenic acid and methanol. You will need your data book to find out what linolenic acid is. And here's